Hello, myself Vaishnavi. I'm going to present on the topic embedded system hardware that is related to the subject microcontroller and embedded systems. The topics we are going to discuss is about introduction to embedded system, ARM bus technology, ARM bus protocol, memory and its type, peripherals. Before knowing about embedded system hardware, we need to know what is embedded system. The term system refers to the arrangement of certain units and components or the way of working. We can also say that there is a simple line that describes embedded system, something that is attached to another thing. And also it has application software and computer hardware. An embedded system is a combination of computer hardware and software which performs particular tasks. Embedded system may also function within a larger system and it can also be an independent system. There are three major components: hardware, software, RTOS. RTOS refers to the real time operating system. This real time operating system performs some set of rules during executing programs surrounding. Here are some examples that are related to embedded systems. These embedded systems are the ones we see in our daily life, like PCs, laptops, smart mobiles, TVs, washing machines. It may be anything that are related to embedded system. Even the fax machines, printers are all interconnected to the embedded. Coming to the main topic, embedded system hardware. Embedded system hardware systems are designed to control many different devices, from smaller sensors found on the production line to the real-time control systems used on NASA spacecraft. These devices are the combination of software and hardware. Each component is designed to provide higher efficiency and is designed for future extension and expansion. Here is an example of ARM-based embedded device. This ARM-based embedded device is a typically embedded device based on ARM. Coming to the topic, ARM-based embedded device. We see that many boxes and lines are considered. Let us know what are these boxes and lines represent. The boxes represent the feature or function and the lines represent buses carrying the data. The ARM processor is connected to the interrupt controller and AHP arbiter. AHP arbiter is the ARM high performance bus. The AHP arbiter is connected to AHP and APP bridge. Real-time clocks, serial UARTs are also connected to this bridge. The memory controller. It has a memory controller because the memory controller is used as per the requirement of memory such as ROM, SRAM, flash ROM, DRAM, and also a AHB external bridge is connected to the external bus. APB refers to the ARM peripheral bus. The Ethernet is connected to the Ethernet physical driver, and counter and timer is also connected to this ARM based device. There are four major components such as ARM processor, controllers, peripherals, and buses that we are going to discuss. ARM processor. ARM is referred to as Advanced RISC Machine. The ARM processor controls the embedded device. They control the embedded device and also found in the embedded in the chips. They're found in the embedded in the chips. An ARM processor comprises a core. That this is used in the execution of the instructions and also helps in the manipulating of the data. Thus, the surrounding components that interface it with bus, and these components can include memory management and caches. Controllers helps coordinating important functional blocks of system. There are two majorly found controllers such as interrupt controller and memory controller. Peripherals provide all the input-output capability to the external to the chip, and this peripherals has the uniqueness of the embedded device and also includes serial input-output, the parallel input-output, timers, counters, and clock circuits. And the buses, this bus supports communication between the different parts of the device. ARM bus technology. Embedded systems use different bus technology than those that are designed for x86 PCs. Peripheral Component Interconnect Bus, that is also known as PCI. This type of technology is external or off-chip built into the motherboard of PCs. The embedded device used on as an on-chip bus, and the embedded systems are more powerful as they are connected on the on-chip. There are two different classes of the devices that are attached on the bus, that is the bus master and the bus slave. Bus master refers to the logical device that is capable of initiating the data transfer with another device across the same, thus also referred to as the bus master is responsible for monitoring and sending the various tasks. Bus slave, logical devices capable of only responding to the transfer request from bus master device or the processing that should be executed. The bus master has a ARM processor and the bus slave has a peripheral device. A bus has two architectural levels, that is the physical level and protocol. Physical level is the electrical characteristics and has busword. Protocol level has the logical rules. Amber Bus Protocol. Amber Bus Protocol refers to the advanced microcontroller bus architecture that was introduced in 1996 and has been widely adopted on the on-chip bus architecture used for ARM processor, that is Advanced RISC Machine. Amber buses has introduced ASP and APB, which is the ARM system bus and ARM peripheral bus. Later the ARM introduced another bus which is called as ARM High Performance Bus, that is AHB. Using AMBA, the peripheral designs that can be that has many designs on multiple projects. This is a plug and tug interface for many hardware developers. As AHB provides higher data throughout ASB, this allows the AHB bus to run at higher clock speed. ARM has introduced two variations on the AHB bus, that is multi-layer AHB and AHB Lite. The original AHB allows only single bus master to activate, but multi-layer AHB allows multiple. The AHB Lite is a subset of AHB bus that is only limited for single bus master. The AHB and multi-layer AHB supports the same protocol of master and slave but have different interconnections. They permit operations to occur in parallel and also allow for higher throughput rates. The external bus requires another specialized device to connect with the AHB. Memory. An embedded system has to have some form of memory to store and execute the code. If the memory has to run twice as fast as to maintain the desired bandwidth, then the memory power requirement should be higher. The memory should be fast, large, and inexpensive. The common solution to have this memory hierarchy. So it consists of a cache, main memory, secondary storage, which gives the data on the memory size and the performance or the cost. All computer systems have memory arranged in some form of hierarchy. The fastest memory cache is physically located near the ARM processor core, and the slowest memory, secondary memory, is set further away. The cache is placed between the main memory and the core. It is used to speed up the data transfer between the processor and the main memory. Though the cache provides overall increase in the performance, but there is a loss of execution time. Although the cache increases the general performance of the system. Memory width. The memory width is the number of bits of memory that returns to each axis, which typically has 8, 16, 32, and 64 bits. This memory width has a direct effect on the overall performance of the system. If the system is using 32-bit ARM instruction and 16-bit memory chip, then the processor will have 2 memory fetches per instruction. This reduces the system performance, but the benefit is that 16-bit memory is less expensive. Sync to the fetching instructions from the memory. It is divided into instruction size that has 18-bit memory, 16-bit, and 32-bit. Instruction size is of ARM 32-bit and Thumb 16-bit. 8-bit memory has 4 cycles in ARM32-bit, 2 cycles in thumb 16-bit. 16-bit memory has 2 cycles in ARM32-bit and 1 cycle in thumb 16-bit. 32-bit memory has each 1 cycle in ARM32-bit and 16. Memory types. There are many different types of memory such as ROM, flash ROM, dynamic RAM, static RAM, and SD-RAM, that is the synchronous dynamic peripherals. The embedded systems communicate with the outer world through the peripheral devices. The peripheral devices performs input and output functions that are connected to each other by the devices and sensors that are off-chip. The peripherals range from simple serial connections that have the more complex such as 802.11 wireless devices. All the ARM peripherals are memory mapped. The controllers are specialized peripherals that have higher levels of functionality within the embedded system. There are two types of controllers, that is memory controller and interrupt controllers. Memory controllers. Memory controllers connect different types of memories to the processor bus. And these memory controllers activate some certain sort of memory devices that need to be execute certain code. It configures that the memory timings and the refresh rate of the DRAM before it is accessed. Interrupt controller. When the peripheral or the device when they require attention, they send interrupt to the processor. There are two types of interrupt controllers such as standard interrupt controller, which is SIC, and vector interrupt controller, which standard interrupt controller, that is known as SIC. The standard interrupt controller sends the interrupt signal to the processor core when the external device requires servicing. Then this programmed to be ignored or mask an individual device for set of devices. The interrupt handler determines which device requires servicing by reading a device bitmap register in the interrupt controller. Vector interrupt controller VIC. The VIC is more powerful than the SIC because it prioritizes the interrupts and simplifies the determination of which the device caused the interrupts. Along with the masking functionality, it also provides functionality to prioritize the interrupts. Depending upon this type, the VIC will either call the SIC exception handler, which can load the address of the handler for the device from the VIC, or cause the core to jump to handler of the device directly. Thank you.